rule is essentially dealing with the composition of functions. And I think for homework, there was a problem that was, it was what in parentheses, it was x cubed. Read me the homework problem we had.
Oh, x cubed minus x whole squared.
And it was squared, okay. So that is a problem that we did by squaring it and then taking the derivative. But in a minute, we're going to look at how we could use the chain rule to come up with the correct solution here. But before we get to that, let's define what the chain rule says. The chain rule says if we take a composition of functions. See, this is a function composed of, I have whatever this is, let's just say it's g of x, and g of x is raised to an nth power. So if I have h of g of x, the chain rule says that f prime of x is h prime of g of x times g prime of x. So it's saying we're going to take the derivative of the outer portion and multiply it by the derivative of the inner portion. Now, there's a special chain rule that is for the power rule, and it says if we have f of x equals g of x, and we're going to raise that to the nth power, then f prime of x, and this should make sense, would be n times g of x to the n minus 1. At least that part should make sense, because that's the power rule basically, isn't it? But then it's times g prime of x. So that's what I'm going to look at solving this problem here. So f prime of x would be the power rule, which says it's going to be 2 times x cubed minus x to the first power, right? That'd be the power rule portion of it. Now we need to take the derivative of this. G of x would be this, so it would be g prime of x there, which would be 3x squared minus 1. 2 times x cubed minus x to the first power, then 3x squared minus 1. Now let's see how this checks out with the homework answer we had. What I'm going to do from here is I'm going to FOIL here. 2 times, all right, this would be 3x to the 5th, right? X times 3x squared? Mm-hmm. Okay. Then it would be minus x cubed minus 3x cubed, and then plus x, right? So it's 2 times all of that, which would then yield 2 times 3x to the 5th minus 4x cubed plus x. Are we still okay? So then we get 6x to the 5th minus 8x cubed plus 2x. Is that what we got for the answer? I hope so. Because I've worked so many problems, numbers aren't looking familiar to me anymore. But good. I'm glad that I didn't make a mistake here.
When I was doing this last night, I accidentally did that. So
That's
it's so cool.
yeah. Yeah, so it just jumped out. So you knew to take the derivative of the inner portion too.
Yeah, I don't know how I did that.
I don't either, but I'm glad you did.
I think I was just desperate for an answer.
You're desperate for an answer, okay. I like that. All right. So are we okay here? Now, let's look at some examples. First off, I want to look at f of x equals cosine squared x. Now, believe it or not, that is a chain rule. What I'm going to do with this is I'm going to rewrite it. Now, you do not have to do this step, but I'm just trying to illustrate what's happening. Remember, what is cosine squared of x? It's cosine of x times cosine of x, right? Or it's the cosine of x being squared. So we are dealing with a power rule here, which says we got f prime of x equals to 2 times cosine of x, and that's it, right? No, that's not it. What else do I need to do here? Of the internal portion, which is cosine of x. And what is the derivative of cosine of x? So we get negative 2 sine x cosine x. Now, if you want to show off here, 2 sine x cosine x is a double angle identity. It's the same thing as sine 2x. So this could also be negative 2 sine 2x. I did see, one year I did see a matching problem, not a matching problem, multiple choice problem on the AP test where you had to know this identity right here. I've only seen it one time, and that's kind of more of a test on whether you know trig or not than whether you know calculus or not. So I think that that's the reason I've only seen it on one test. I think that, but it could happen again. So just know that 2 sine x cosine x is the same thing as 2 sine of 2x. But that's not calculus, that's trigonometry. All right, now let's try this one. Y equals to the cosine of x squared plus 1. Now, I don't know why I'm stuck on cosines today, but I am. Here we're looking at the derivative. The outer portion is going to be the cosine of the angle, and then the inner portion is going to be the angle. So what is the derivative of, and watch how I word this. I'm not saying what is the derivative of cosine. I'm saying what is the derivative of cosine of an angle. So the derivative of cosine of an angle is the negative sine of that angle, right? And now, what's the derivative of the angle? 2x. So we can get negative 2x sine of x squared plus 1. So the derivative of cosine of an angle is the negative sine of the angle times the derivative of that angle. Now, in the past, what have we had? We've had sine of x. Well, what is the derivative of x? 1, right? The derivative of x is 1. So we're really doing the chain rule. We're just saying it's this times 1, but we don't bother multiplying the times 1 there. Biggest mistake made here is people saying it's the negative sine of 2x. You don't take the derivative of the angle and the derivative of the trig function in the same step. It's always, cosine is always going to be associated with this angle, so if it's associated with that angle, then you go from there. Are we okay to keep going? Okay. All right. Now, you've really got to be careful when you're dealing with a composition with a quotient and a chain. Sometimes the big picture is the quotient, and sometimes the big picture is the chain. In this example, the big picture would be the chain. But if I write it like this, now the big picture is the quotient. So this is a chain rule with a quotient rule inside of it. This is a quotient rule with a chain rule inside of it. Well, the derivative of it's 1, so it's not really that big of a deal. But anyway, let me change it. Now the chain rule becomes important there. Okay, so let's look at solving this one out. So the first thing says I take the derivative of the outer portion, right? So y prime would equal to 3 times x plus 4 over x squared minus 1 to the second power. And I'm done, right? No, I'm not. Good. Y'all got it that time. All right. Usually when I say and I'm done, usually means I'm not done. All right. Now, the next part says we got to take the derivative of the inner portion. What do we have as the inner portion here? Quotient, right? So it's going to be x squared minus 1 times, what's the derivative of the numerator? 1. I almost thought I heard someone say 4 there, but I know I didn't hear that. All right. And then it's x plus 4 times what? 2x. And then that's all over x squared minus 1 squared, right? Everybody fine with what I have here? All right. Now, this is 3 times, I'm going to write this as x plus 4 squared over x squared minus 1 squared. I don't know if that's going to help me or not, but anyway. Now, let's clean up the numerator of this next fraction. So, I got x squared minus 1 here, right? Now, this would be minus 2x squared minus 8x, right? And then that's all over x squared minus 1 squared. All right, let's keep cleaning up. All right, so this is 3 times x plus 4 squared. I think I'm off the board. There we go. All right. I would have had a lot of disappointed viewers at home if I hadn't done this. All right, so what comes next here? X squared minus 2x squared is? X squared minus 2x squared is? Negative x squared minus 8x minus 1. And then it's all over x squared minus 1. This times this would be to the 4th power. You could factor a negative out and make it negative 3 times that with a plus there, but that's not a big deal. Everybody okay here? All right, now let's look at this quotient that has the chain rule inside of it. Again, this was a chain rule with a quotient inside of it. This is a quotient with a chain rule inside of it. So I've got x squared minus 1 cubed times what there?
X plus 4, 8,
Mm-mm. 1, yeah, because the derivative of x plus 4 is 1. All right, minus x plus 4. Now's when we get into the chain rule, right? So how do I take the derivative of this? Well, it's 3 times x squared minus 1 squared. Are y'all with me? And then times, and what's the derivative of x squared minus 1? 2x. And then, hold on just a second. Let me get this written down before I forget it. All right, what's your question?
Is that a 3 in the middle of x plus 4 and x squared?
Yes, because this came from the power rule here. It says 3 times x squared minus 1 to the second power. So it's 3 times x squared minus 1 to the second power.
So far away from me.
Okay? All right, let's clean up now. Remember earlier I said it's best not to distribute that out. And the reason is, if you look in the numerator right here, this is a binomial. This is the first term of the binomial, and this is the second term of the binomial. And both parts of the binomial have an x squared minus 1 squared in it. So I'm going to factor that out of everything. So I'm going to have an x squared minus 1 squared factored out. And then from that point, I have an x squared minus 1 left over here, because I factored 1 out from the 3, or 1 term out from the cube, I should say. And then it's minus, all right, this is all gone, right? So it's just 6x times x plus 4. Again, I asked Santa Claus for a new handwriting last year for Christmas, and I didn't get it. So what happens here? The 2's, that becomes 4, right? So I've got x squared minus 1 to the 4th power. And then let's clean up the numerator. This is going to be x squared minus 1 minus 6x squared minus 24x. Are we still okay? All right. And then it's x squared minus 6x squared, which is negative 5x squared minus 24x minus 1 over x squared minus 1 to the 4th power. Do y'all realize across the United States of America today, we are probably the only class that solve for the derivative of x plus 4 over x squared minus 1 cubed?
Beautiful.
We're in pretty high company there.